but these are good ideas. And Jacob, you mentioned something about sort of the interpretation of your results, and including that. And you know, I actually think the three of you, you all did quite a bit of interpreting your results in your videos. There are a few of the other videos that are they're really about just stating whether or not they saw a correlation in whatever research question they were pursuing, but they didn't really provide any interpretation. And so we had a couple questions in our feedback here that were going to be about that, but I don't think it's as relevant to the three of you, actually. Maybe another way to ask those questions is, how did you know that you should include interpretation of your results in your video? Did anything in the instructions prompt you to do that, or what made you want to do that? Which was the right thing to do. It's just some students didn't.
I just remember from the previous video we made for the class, we included a lengthy section on interpretation. And I thought it's always good, just like when you write a paper, to discuss the error, to discuss your interpretations or various other theories that may support or disclaim what we've said, so that that uncertainty is still factored in.
Right, right.
In my case, I had some data sets that, or some separate filters for data sets that by themselves seemed a bit edgy, but with the interpretation I could get them to actually make a point. So I separated out the data into two sets, one below the mean distance and one above the mean distance. And if I just included that, those two histograms, that wouldn't really make much sense. But then with the interpretation, including some other stuff, it actually made some sense to include those histograms. So it was more about having the data make sense by itself didn't quite work, but having the data make sense through the interpretation of the data worked to explain it.
Right, right. Yeah, in many ways your research question like forced you to have to say, I think this is because X, Y, and Z. Yeah. Then there's some questions about the tools themselves. So one thing you brought up already is that you ran into this 2 million cell, or probably less, 250,000 maybe row limit. And so that made you use the data differently because of that limitation. Any other limitations or problems you had with the tools that we should be sure to have on our radar and we could talk through a bit?
The tools didn't work in Firefox for me, so I used Google Chrome instead. Yeah, that's one thing. Everything worked. I just found it a little confusing trying to do the research on top of learning how to use the Google Docs at the same time. So that sometimes I would figure out how to use the Google Docs after I've tried to start the research, and then I'd mess up what I was doing.
Yes. Our hope, so in the course, the setup is the students will do a series of in-class activities where they're learning the tools, and then maybe a third or two-thirds of the way into the class, that's when the research project will start. But the comment in general is instructions how to use the tools we're going to think more about as well.
Did Jennifer and Rebecca, did you get a chance to watch the video of our initial discussion in early July? And was that not helpful at all?
It was helpful.
Okay.
I did watch that. I did watch it, yeah.
Okay, cool.
What about, did any of you have the trouble where if you use the filter tool but you haven't renamed the tab, it would cause difficulty?
I've never renamed any tabs.
Or a new sheet? Or a new sheet within your Google Sheet. Maybe not.
I mean,
Okay.
sometimes it took multiple tries to get the data to properly filter, but it seemed to me like that was just an error with loading, and that it just couldn't get through the data in a set time, and then it just gave me a blank sheet. But it always seemed to work if I just redeleted the sheet and then redid the entire thing.
All right. Yeah, that came up a couple times. I think we should just have some, like, write the statement that we know this happens, so when it happens, just delete and try again. It is a timeout error, you're right. What about, so as you make a plot, so you made a plot of a histogram of mass for spirals and a histogram of mass for ellipticals. Was it totally fine to just compare them side by side? Yeah, was there anything about the making comparisons that was easy or hard, or suggestions you might have on those?
Making comparisons was easier when I copied and pasted a picture of histograms to a different document, so I could have them all up at once.
Mm-hmm. And did you just copy paste into another, like a Google Doc or like a Word document, or where did you move them to?
I copied and pasted them to a Word document.
Gotcha. Yeah.
I mean, I downloaded all the histograms and all my plots and just look at them with, I think, Adobe Acrobat or something like that, because it made it easier to just have them side by side and be able to manipulate them using the desktop as a whole rather than have them integrated into the sheet.
Mm-hmm.
But I think it would have been fine to just use it in the sheets as well.
Yeah, I have a feeling a lot of students will do that and did that. Was it frustrating and annoying to do that, or was it fine?
No, it took 10 seconds or so for each plot. It was no trouble or anything like that.
And was the statistics tool a helpful one and easy to, I guess, user-friendly, easy to use, easy to interpret?
I mean, for me, it was really helpful because I managed to use it to first figure out that there was some data in my that I couldn't really use because I didn't know that the near cluster distance was logarithmic. So that helped because suddenly the minimum was -800 and the mean was around -20, and that explained a lot. But then the statistics was very easy to use, and I thought it worked very fast as well, so I thought that was a good tool.
Yeah. Okay. Anything else about the tools themselves? Well, that in itself is actually a really good thing. We did a very different project, but a previous iteration with some custom built data analysis tools, and they gave us a lot of trouble. And so we made this choice to use Google Sheets and just build on top of those. And I think the lack of sort of real problems or issues is a good sign. What about, in general, if you had been given a data set and you could use any tool, data analysis tools you wanted, what would you have used?
Because I'm working with it right now, I don't know if this would be accessible, but I'd be using IDL because it plot the noise and you could analyze arrays much more easily.
Right. And that, yeah, so definitely for more advanced students. that's the type of thing we're thinking, or Python or some other. Yeah. What about for you, Jacob?
I probably would have just used functions written into Google Sheets and worked my way through with that and just made it work. Because, I mean, I don't have any real data fit tools that I can easily get access by myself, as of right now at least. And so I would have made it work somehow, but ZooTools was definitely very helpful with that.
Right, right. Have you used Google Sheets in your class work at school?
Yeah, so my school works with Google accounts, so I use Google Sheets and basically all of Google Docs for everything.
Right. Sort of banking on more and more students having some background because of what they do in high school.
Mm-hmm.
Google Sheets. Yeah. All right. Let's see, Julie. Any other questions? Or yeah, anything else?
I haven't thought of anything based on their responses yet.
What about for you all? Any parting final suggestions, comments that you want to be sure we have in mind? What about if you were to redo this summer, would you have spent these, oh, maybe it was about 20 hours total or 25 hours total, again working on this? Was it useful, interesting, fun, anything? or you can also say, not really. I don't think I would have done this knowing where I'd get to.
Yeah, I would have done it again. I would have picked a question with an actual answer that was not no answer, but yeah, I would have definitely done it again.
I'd do it again. I'd do it again with a better question. I wasn't happy with the question I asked.
Actually, that is a question we wanted to ask. So, Jacob, you said your question came down to that didn't really have an answer. There was sort of like a null result. Is that a very frustrating? Was that very frustrating? Would that have the possibility of turning you off from wanting to do more research? Like, what was the sort of emotional result of that? And it's important for us to be thinking about it because a lot of questions will end up like yours.
I mean, I thought it was fine. I disliked the fact that my hypothesis was wrong, of course, but I would have just, if I had a different research question, if I'd actually been working for more than this class and had more time, actually, I would have just picked a different question and tried again. Because, I mean, I was expecting that more likely than not I would get something that had no clear result. And in my case, actually, the result was pretty clear, but it was that there was no relation. But so I would have just picked a different topic that probably would have had an answer, in my opinion. I just kept trying until I found something with a relation.
Right. Hearing you say it like that makes me feel optimistic that this might motivate students to want to know more. But what I'm concerned about is students have that experience and then say, research is not a rewarding, not rewarding, or some kind of negative emotional response to it. Which is not what we want. But
one thing that I did find slightly I'd like to note is that even if this was supposed to be, please talk to Seth for me about the research project, is that when I think of research, I think of it as you going out finding the data, or at least being led to a place where you could get the data from. Like if you want to look at planets, you'd be guided to look at the Kepler mission and nothing. He's talking to someone else first. Okay, and downloading the information. I found it strange to have it as a research project when you're given the specific tools and specific data set to look at.
Mm-hmm. Yeah, yeah, there's not the freedom to choose your own data, and you're even constrained from the beginning to like a general research area. Um, yeah, do you have any suggestions for what might make it feel like there's more freedom, even though we still will constrain the students to that data set and using that?
Maybe providing, and probably because I didn't look at the extra tab, more information on galaxies and stars so that you at least have something to build on before you start using the research, or at least you can start thinking about things outside the research.
I think that if it's clarified that the tabs actually have some information in it with the links, and then also just clarifying that that you don't have to look for a trend that utilizes all 12,000 data points. I think that'll give it a lot more freedom, and it'll also make it seem like there's a lot more freedom, because at least for me it seemed a bit constricted because I didn't know about the specified, very actually pretty cool information in the links that I was looking at a few minutes ago. And then also that I would also just pick about 100 outliers for something and look at those 100 outliers or so.
Right. That is all really helpful to hear. Very helpful. All right. So with that, any final? Well, obviously you can email Julie or me anytime with additional thoughts. If you haven't yet filled out doing the second time of the Nature of Science survey, Julie emailed it about it. Definitely do. That's helpful for us to see sort of a pre and post. And then otherwise, just a huge thank you. Your help is really, really, really appreciated with this. So clearly, we have a lot we're going to update, and then we have a lot we know that is going okay that we can sort of build on. So, yeah, thank you.
Thank you.
Excellent. Have a good rest of your day, everybody.
Thank you very much. You too.
Thank you.
Bye. Oh.
Oh, okay.
Hello. I will unmute myself. Unmuted. Okay. I think it's that my mic and your computer. So turn your computer on mute. It is. No, your mic is on mute, not your computer. Okay, so I'm Julie. I work here at Adler Planetarium, and I've been developing the material that you will be helping to test out for us. Today, I'm just going to go over some activities and some background so that it should help you get started. Does everybody want to, maybe we should have everybody introduce themselves. Lara has already introduced herself, and we have Cameron here, who is our intern this month. I'll let you introduce yourself.
Yeah, my name is Cameron. I'm a senior at Northwestern University studying learning and organizational change, and I am interning here at Adler.
And then, Jacob, if you would like to introduce yourself.
Yeah, I'm Jacob Reinke. I'm an incoming senior at ETHS, and I was asked to do this by my physics teacher, Doc V.
Cool. Well, thank you for joining us. And then, Frederick, would you like to introduce yourself?
Hi, I'm an ETHS student too, and I'm doing this because my physics teacher asked me to.
And I love DocV, so thank you, DocV, for recruiting. And then there's 8 students total who are helping us pilot test this summer, and so I'll do a broad introduction. But there are a little all around the country, and they're both undergraduate students and high school students. So thank you again, everybody, for helping us with this.
Thank you very much. We really appreciate it. So this whole thing is really a part of developing a research experience for an introduction to astronomy classroom in college. So non-majors are really taking this class, and it's meant to fit into the class, and we'll go through a couple of the activities that fit into the class that introduce you to tools to use for the research project we'll have you do. So I'm going to go right on ahead and do that. So I'm going to share my screen. All right, so everybody should see this thing that says welcome to the Astro 101 tools. And
Actually,
oh, you could see it. Okay. So these tools, as it says on the site, is developed to enable you, the student, to be able to view, analyze, manipulate, and visualize astronomical data. And for the first activity, we're kind of introducing data to you. And using what we've done with students in the classroom is we've asked for their hometown information versus their institution. If you have access, I don't know if Laura sent this link to you before, but I will do so now in the chat box so that you can have access to this website as well. You click on the Google Sheet, which actually I already have open, and you'll see that we've tested this out with the University of Minnesota before. And I'm actually going to ask one of you, how about Jacob, since you arrived first, to go, I'm going to guide you through this activity so that you get some practice using these tools and everything. First question, did everybody has the Zoo Tools for Sheets add-on installed?
Mm-hmm.
I added it, I think.
Okay.
I have it as well.
Okay, good. So as long as everybody has that on their add-on, and anybody who watches this later, it doesn't show up, please email us. We'll help you get that installed. But for this activity, we asked students to fill out a survey, a student location survey, of putting in their institution and where they were from. And that's how this sheet has been populated. And you'll notice we have some testers or some outliers in there that don't actually go with University of Minnesota. So the first thing I'm going to ask you to do, Jacob, is you go to your add-ons, and what we're going to do is we're going to filter out just the University of Minnesota folks. So I'm going to copy the information from this one sheet here, and then open up Zoo Tools and go to Data Filter. All right.
Mm-hmm.
And then with the data filter, you'll see on the side here it says first filter, and there's like an explanation for you to go back later if you can't remember what it does exactly. But we want to filter out all the what is your institution data that equals that University of Minnesota, Minneapolis, Minnesota, United States. We don't need a second filter. We do want to compare the filter to the whole data set. And so then you just hit filter. And then a new page pops up. So I will go ahead and delete this and let you, Jacob, do that yourself. And so then we can then look at the filter data that you've set up so that it's so that you get some practice with that.
Mm-hmm. So where would I find the link?
Oh, do you have the form open?
I don't think so, no.
Okay, so the link to this website I put into the chat box for this Google Hangout.
Okay, then let's see.
And then you click on the Google Sheet and this should pop up.
I can't find the link on my computer.
Okay, how about I'll just run through things and you guys can do it on your own computers. And that way, you know, you're also running through it with me. Keep hearing somebody messaging me, but I can't get to the message.
Maybe, Julie, the link itself is short enough. You could just spell it out because it's just the github.io, right?
Yeah, so it's ZOONIV.
Oh, it was the Zooniverse link?
Yeah, the Zooniverse GitHub.io intro to Astro. That will take you to this website where you can get to the Google Sheet for this activity. Does everybody have this sheet open? I only see one person on it. But...
I have it open.
Okay.
My computer is still giving me some kind of error.
I have an anonymous box that showed up.
Am I
Yeah, you are there.
not an anonymous?
You're not anonymous because I have your email saved. But everyone else, I think, would be anonymous except for if Laura got onto the sheet.
Hey, Jacob, maybe do you know how to share your screen? If you could show the error, I might be able to help figure out what's got, because an error you see, other students may see as well, so it might be worth testing.
Yeah.
I mean, the error that I'm seeing is that my webcam isn't working, so I have to use my phone as a video while I'm using my computer as the computer.
Mm-hmm.
So I'm trying to, I just can't get to the link at all.
And so on your computer, are you at the Zooniverse.org or Zooniverse Oh, what's the GitHub? The
Universe.github.io backslash intro dash to dash astro backslash.
Sure. I'll also I'll send that to you in an email.
So it's intro to Astro. Is there anything at the end of that link then?
No, it's just GitHub or zoomers.github.io slash intro to astro slash or backslash. Those two slashes were backslash. But intro to astro is intro dash to the number 2 dash astro.
Then that would be my error. There we go.
Great. Okay.
Now,
Better that it's a spelling error than or a typing error than a actual access error. That's mainly we want to make sure access is possible for anybody using these.
Yes.
Great.
And now there's more anonymous people on here. Yay! Okay. So going up to the add-ons, you want to select the data filter helper, and you want to filter out all of the University of Minnesota, Minneapolis. So to just make sure that I had gotten that exactly, I just copied one of the fields and then went to the data filter helper, which shows up to your right. And then I selected to first filter what is your institution. And I want that to be equal to what I had copied, the University of Minnesota, Minneapolis, Minnesota, United States. And then towards the bottom of the filter, you want to hit compare filter to whole data set, which will make it so that all of the information from those lines that have what is your institution set to University of Minnesota will filter out. And then just hit filter, and then we should all see your filtered data down at the bottom, which then we can click on that tab and then see that all of that data has been filtered. And all right, cool. So from the data that we got from those students, what we had asked for were these two questions. Where are you from? By the way, Jacob, thank you for doing that. So the where are you from and what is your institution? And you can get other pieces of data from that. So we've generated this form to take the location and give us the student's latitude and longitude of their hometown, and then their institution's latitude and longitude, and then also calculating the distance. So we've been able to generate data based on those two bits of data that the students gave to us. And this happens for a lot of different things that you use in, like, just entering in data on a website when you're, wanting to sign up for, like, getting emails or getting free samples in the mail, or when you sign up for even a Google Gmail address. If you are giving like location or your phone number, they can get information about where you're located. Not your exact location at that moment, but they can get that information. So this is how a lot of stuff in everyday works. And so what we're going to now try to visualize this data. First thing I'm going to show you guys is that we have a map helper. So that's like a sort of obvious of how to visualize this data, let's look at where the students are from, their latitude and longitude. And then we can see where all of the students are from that are heading to this class, that were in this class at University of Minnesota. What do you, just looking at that map, what do you guys have to say about that so far? Like, does it seem like a lot of those students are coming from far, coming from nearby? Is there something else that you notice from looking at that map?
A lot of Americans.
A lot of Americans. It is an American institution, so yeah, you can get a lot of Americans there. We can also zoom in and see specifically where in the states these students are coming from. So some students are coming from pretty far to go to University of Minnesota, which is around here. But it looks like there's quite a lot of students right there. Is there anything else that you guys notice? Where do you think is the furthest location that students are coming from? Maybe these students over here in China, they could be coming from the farthest. There's also a student in Africa. There's students in South America, and you can also see this from looking at the data sheet. You can look through it and see what their hometowns are, but it is easier to kind of visualize the data by mapping it out like this. All right, so next thing I'm going to do is let's play around with other ways to visualize this data. So a map is really just a scatter plot. So let's have one of you put together a scatter plot. Jacob, could you also do this, and then we'll have someone else do one of the next activity. So let's go to scatter plot helper.
Mm-hmm.
And we want to look at the student's latitude and longitude again. And then you can just hit plot. And it'll show you a little plot, but if you send it to sheet, then a chart will show up like that. Okay. So looking at this student latitude and longitude, does that tell us the same kind of information as the map did? Can that give us as much information as the map did?
Not really, no. It gives us similar information, but the map makes it gives the distance more of a precise nature, in the sense that you can see that, because of course the Earth is not flat, the distance is not as simple as just going one way or another. So I think that the scatter plot with location has a lot of downsides that the map doesn't have.
Yeah, so the map, specifically when you're talking about latitude and longitude, gives you something that you can relate to. It's a better way to visualize student latitude and longitude. or even institution latitude and longitude, you can see directly where students are coming from. Whereas with this, you're kind of like, well, I know like this part of the world might be over here or whatnot. You can say like, I know that this is, you know, the northern hemisphere or the southern hemisphere, but that it doesn't give you as much information as, say, the map does. So going back to the student responses, let's also look at another way to visualize the data. Let's look at the histogram helper. And so with the histogram helper, we can look at the distance, because that is something that you mentioned, is that, you know, looking at the map can really tell you about the distance. So the histogram will give us a plot that shows us the distribution of students' distances if we look at the calculated distance in kilometers. So when you select calculated distance in kilometers and hit plot, and then you want to hit send to sheet once it's done drawing that plot. There's also this bit of information where you can do more, and you can edit how many buckets you get. So if I change it to 10, and then I hit plot, I will then get more buckets. So number of students in each bucket. I'm not explaining it well. It'll give you a finer, more detailed of how many students are within this distance, how many students are within this distance. And you can, I think it goes up to 20. So you can do up to 20 buckets. All right, and now there is a histogram chart data down at the bottom. So in charts, we now have this histogram. So what is this histogram really telling us? Because we have calculated distance here, so that's the distance the students are from their institution. And then frequency is really the number of students that fit within this bucket. So fit within 502 kilometers from the institution. So what is this really telling us? It's really telling us that most of the students are right there, right nearby. So that a lot of the students from this class were from within 500 kilometers of the university. They're not traveling from very far. And if you edit the bucket size, you can see even closer of how far away they are. So like with my having changed the bucket size to 20, I was able to see that there were 22 students that were within 250 kilometers of the institution. So a lot of them are from, right in Minnesota, which does make sense. A lot of students will stay in state or even be from that city with a public university like University of Minnesota, or at least that's how it generally works in the States. But then there are 3 within 750 kilometers. There are 3 within about 1,250 kilometers, and so on. And you can see one person is within 10,000 kilometers. So they came from the farthest, that one person. All right. So lastly, there is another way to visualize the data that you have here, and that is to run statistics. So we have a little summary stats helper. Jacob, if you could also run the summary stats. When you open that up, it again opens the tools to the right side, and we can run statistics on the calculated distance again. So you hit calculate, it calculates it. If you add it to sheet, then everybody can see it again, just like the other plots. Thank you. And so the calculated different, let's widen this up. So the minimum distance that somebody traveled to get to the University of Minnesota for that class was 2 kilometers approximately. The max was that 10,050 kilometers, so maybe one of the students from China. And then the mean, so the average is about, let's say, about 2,000 kilometers. And then there's a standard deviation, which if you guys were in a physics class, maybe you've heard of all of these things before, but the standard deviation kind of tells you where the normal range is. If it's within 3,090 kilometers of that mean, then they likely aren't outliers that would really like pull the average one way or another. So that person who is the max, that 10,000, they are not within the standard deviation. They are not plus or minus 30 or 3,090 kilometers. So this kind of just gives you a little bit of statistics that you can run on any sort of data. And this is something that can be used for the project that you guys will be doing for us. Does anybody have any questions about this activity or how to use the tools? Okay. If you have any questions at any point in time, please stop me and we'll address the questions. Otherwise, I will go ahead and head on to the next activity. But this kind of gives you just a thing to go about with the data. Cameron, you had a question.
So when I try the map helper, it is only showing me, do I have to highlight do I have to highlight all the responses, or because I'm only getting 1 point, and I guess it's just the point that I'm on at that time.
So you have to click this because look, it's saying calculated distance. So you have to select that you want the student's latitude and longitude.
Okay.
Just so that everybody can see what Cameron was asking me about.
Okay, so that's input data rather than...
Yeah, so you have to change these things here if you want the map to work. So if you want to look at the institution latitude and longitude, you have to actually plug that in and map it.
Cool.
So this is using our first sheet here of the student responses, which includes some of our extra data points.
Awesome.
But yes. No, it's a good question. You want to make sure everything is working correctly. All right. So moving on to activity 2 from this website. We have another sheet here that if you open up, it looks like this. But first, I'm going to show you guys, I would make a copy because you guys cannot edit this file. So I'm going to go ahead and make a copy. Go ahead and close those. I'm going to show you something first before we go and play around with this file. So first, we're going to look at the black body curve of a star. There's this website through University of Nebraska-Lincoln. And actually, Cameron, I'll let you sort of use my computer to run through this activity, and I'll talk you through it.
Okay.
So we're going to try to learn about a relationship that you'll need and you'll be using in the research activity. And first, let's look at this plot here. So it's wavelength versus flux. So like luminosity. So it's measuring we're looking at the magnitudes of stars. Magnitudes don't have units, but they tell you how bright a star is, or the luminosity of that star in that particular filter. So that there's a lot of different filters here. There's the U filter, the B filter, the V, the R being displayed here, and those coordinate to a specific wavelength of light. And you can kind of see how they are on this plot here. So there is the U filter, the B filter, the V, and the R, and they're measuring light just within those wavelengths. And we're going to look at 5 different temperatures here to kind of give you an idea of a relationship that's used in astronomy quite often, and it's the color index, really. And it kind of will tell you what color that star is, whether it's more towards the blue end of the spectrum or more towards the red end of the spectrum. So when you actually visually see that star, does it look more blue or does it look more red? And I'm just going to have you, so I have 5 temperatures here, and you can run through those different temperatures and then tell me what you notice about this color index. So starting off with 3000, so this is the temperature of the star. Just hit enter. So we have a color index of 1.65. So then if we change this to 9,000, what do we see? All right, so the temperature increase, we have a color index of 0.06. So as we increased the temperature, the color index decreased. And note that under here it says, note brighter stars have smaller magnitudes. So what did we just learn from seeing that temperature jump from 3000 K to 9000 K?
The hotter star has greater luminosity.
Yes, so the hotter star is brighter. And then if we change this to 15,000 K, you can also see how these filters change when you change the temperature of the star. All right, so what happened to the color index?
Dropped.
It dropped again. So we're continuing the trend of the star is brighter with a smaller magnitude. The star is brighter with the higher temperatures. All right, so then if we change it to 20,000 K, then we get an even lower color index, and then let's just do 25,000 K real quick. And again, it gets lower, not by as much, but we only change the temperature by about 5,000 K. So I've already taken all these and I put them into a Google Doc. And you guys are welcome to do your own Google Doc if you want to while doing this. But Cameron, if you want to go ahead and look at a scatter plot of the, you want to do B minus V versus temperature. So the X variable is the B minus V. So hit refresh data when it says no variables. Sometimes you need to hit refresh. And then, so B minus V versus temperature. Not for this. So sometimes we included these aspects here, this invert, logarithmic, because those could be useful for you or they could have been needed for one of the other in-class activities. We will use invert for this activity, and I'll have another person do that activity. Frederick, you'll probably do that activity. So go ahead and scroll down, and then hit plot. And then you can do send to sheet, but you can also see a preview of that plot. So what do we notice with this plot here? So if B minus, what is B minus V telling us versus temperature? Are they increasing together? Are they decreasing together? And remember that a smaller B minus V, a smaller magnitude or color index will tell you that the star is brighter.
They're inversely related.
Yeah, they're inversely related. So when the color index is smaller, the temperature will get higher. It's a relationship that we can use. And you can use even in the research project that we have you do. So that is just a cool little thing to know. Since I know most of the people who are working on this may not have participated in an astronomy course. You two have come from physics classes, so this is good to know that relationship. So now we're going to go ahead and go on to activity 2, where you all look at this. Frederick, if you go ahead, like everyone walk through this on your own. I was just realizing that you guys can't edit this sheet, but so everyone walk through this on your own, especially Frederick, so that you can get a chance to practice as well. But so this, let me start over again, sorry. Each of these tabs correspond to a stellar cluster, which is just a grouping of stars that are gravitationally bound to each other. And they are usually all born around the same time, so their lives are quite similar. They've been developing in a similar environment.
What's the threshold for like gravity bound? Like, because isn't there always some level of like interaction between stars that are far away?
Yeah, so these stars are all kind of orbiting around. I keep hearing like a click, like somebody is sending me a message, but I can't see the messages. Anyway, so all of these stars are orbiting around each other around the same point. It would be different for each cluster, I believe, as to what the limit is of like where stars are part of that cluster
Okay.
or not part of that cluster. But it's a good thing to think about. But yeah, so that is an aspect. What we're going to do is we're actually we're going to try to make this plot. It's called the Hertzsprung-Russell diagram, or HR diagram is what we call for short. And each of those clusters we can make an HR diagram from. The HR diagram is something that you'll commonly see when you just Google things about stellar clusters or want to know about types of stars. It really can tell you about the lives of stars.
Hi.
Hello? I don't know if that was in the background of somebody else's thing. So main sequence stars, which is like pretty much the main part of their life. It's kind of, you can sort of say it's like their adulthood. Stars aren't generally born along the main sequence, from what I remember. They end up developing into the main sequence. And there are stars that are more red in color, so you can see the temperature affects the color of the stars, which is what we noticed really with that B minus V, that color index and temperature. So color and temperature are very closely related. A more blue star, which is the stars that are going to have smaller color indices, are hotter, and then the stars that have a higher color index are more red in color. So that relationship is used in the HR diagram. And then there's luminosity along the y-axis. There's also other features to the HR diagram, like the fact that as you get more towards the top right corner, stars radii are larger. When you go more towards the top left corner, stars are more massive. But we're going to really focus on that temperature relationship in this activity. So we have all these clusters, and you guys are welcome to play around with whatever stellar cluster data you want. Just make sure that you make a copy, because I believe no one's allowed to edit this. I don't think I'm allowed to edit it, so I'm going to just do the make a copy as an example. And I'm just going to change this to and then I want to make a copy. It's working on it. Alright. So I've made a copy of this file so that I can make my own plots and whatnot. It'll tell me to make a copy, but I have made one. And I can go into the ZooTools for sheets and create scatter plots or a summary of stats, whatever. But what I want to do for this is I want to try to recreate this HR diagram. So I want to look at the temperature versus luminosity. And since we learned that B minus V is the inverse of temperature, And then something that I'm just going to tell you now is we're going to use V as the luminosity because these are all magnitudes. The luminosity is a magnitude. So I'm just going to go to a scatter plot and do the x variable is going to be b minus v, but then remember we have these interesting things that we can use. And we're just going to click invert b minus v. And then for the y variable, I want to plot the v because that's going to be our luminosity. And then I click plot. It gives me a little sample of the plot. I'm going to send that to my sheet so you guys can see it bigger. All right. So can you guys sort of see a main sequence at all? Just to say first that this is clearly a drawing, like neatly, tidy for a book so that you can see in clear detail where stars go. But looking at the plot that you created or the plot I created, can you see an HR diagram? Do you think that this shows you sort of a main sequence? So what I sort of see is I definitely see this line that you kind of see with an HR diagram where the main sequence goes from one end to another. But there seems to be this sort of turn-off point. And that could be the fact that, like, when stars lie in these other parts of the HR diagram, they're at different times of their life. But this can tell you a lot about how hot these stars are, how blue these stars are. So in comparison to, so we know that stars down here are more red, stars up here are more blue. Does anybody have anything that they notice about this plot? Or their own plot? There's outliers, yeah. So like if we ran the statistics, we'd be able to find like the standard deviation and see that there, like what exactly are outliers, what are not within the normal standard deviation. There's probably a good chunk of outliers right up here where there's this turnoff of stars that are maybe changing. Does anybody have any questions about what they're seeing or confused at all? Okay. So you just plotted an HR diagram, and that tells you, again, about, it can also tell you about the lifetime of the star, because something else to know is that bluer stars are stars that are burning fast. They're, you know, live fast, die young sort of stars. They're burning up their energy faster by being brighter, by being larger. And so their lifetimes are shorter. So that's something also to know and think about. So a lot of these stars, when you look back to the plot, these stars up towards the top left are going to have shorter lifespans. So that might be why some of them are sort of turning off into a new area of the HR diagram. But for each of these clusters, you're going to see something different. Minus B inverted.
Why do we invert?
So B minus B, remember, is the temperature.
Yeah.
And B minus B is inversely related to temperature. So you can think of it as temperature equals 1 over B minus B. So if I plot this one, I'm going to get a slightly different looking HR diagram.
Was last one with that invert?
Yes.
Yeah.
Yeah. You definitely, if you're plotting an HR diagram, you want to make sure your B minus B is inverted. So you can sort of see an HR diagram with this one, like the ones that you see in the textbook, where they are trailing off, but some of them are down lower. There's a lot of outliers here, right? You're seeing a lot of different things with this one. Does anybody have any questions when they see this one in comparison to the old one? I will see if I can drag this. Yeah. You get a lot more heading off in this direction. So when you look at the Hertzsprung-Russell, that could be that they've developed into giants or supergiants, which can happen with a lifetime of a star. They can become giants or supergiants. There's been talk about what happens to our own sun, and it will likely develop. They usually trail off of the main sequence, and our own sun is right here on this diagram. And they can trail off into giants or supergiants depending upon what type of star they are, which we type them by their color and their size and whatnot. So these letters down here in this HR diagram are actually used to type stars. Does anybody have any questions about this activity? Are they confused at all? Okay. Again, if you have any questions at any other point in time, do stop me. I'm happy to answer them. So something that we're going to go over just to make sure that you are sort of set up. So the instructions for this summer testers were sent to you in the first email from Lara to ask you to fill out the doodle poll, and Lara can resend that email if necessary. But we just kind of wanted to go through some introduction to Galaxy Zoo with you. So you were asked in that email also to go ahead and play around with Galaxy Zoo and check it out, because Galaxy Zoo is the project that you will be taking data from to do research on. I have a copy of the data right here that you will play around with, and you can use these tools that we gave you to separate those out. The introductory activity will really help you with playing around with that data to make sure that you know what to do with it and whatnot. But you'll make a copy, just as all of our other sheets asked you to make a copy. You'll make your own copy of this, and you'll be submitting it to Lara based on these instructions that you were given. But we're going to talk about Galaxy Zoo for a bit. So Galaxy Zoo is a project that uses the Sloan Digital Sky Survey data. It's basically a telescope that was set up to take a very large amount of data of the sky because they wanted to look at galaxies. They wanted to be able to study galaxies. And initially, when Galaxy Zoo was being started, there were these researchers that had a problem. They had way too much data that they themselves could not go through all on their own. Computers have a hard time discerning details. So especially with galaxies, and if we use our human eyes, we can pick out those patterns a lot better than computers can on their own. Computers might be able to get better or learn from us teaching them, but it really takes us, our human eyes, our detail, to help them recognize those patterns. But with Galaxy Zoo, many research papers have been published thanks to people going on there, and just as you may have seen if you went on to the website, which I will show you now, galaxyzoo.org. So you were asked to go on here and classify, and those researchers I was telling you about, they decided to build this website to have anybody help them go through images of galaxies to make their research possible. I believe it was that the initial researcher was a postdoc at University of Oxford, and he was given like 50,000 galaxies to classify within a certain time period. And he just thought that it was very frustrating. I think he got through 50,000, but was not quite mentally stable or happy after just staring at galaxies every day, all day long, and asking these questions to best classify the galaxies. So every scientist sort of has like a thought process that they kind of go through to figure out what type of galaxy it is. And with Galaxy Zoo, he and another researcher developed it so that it goes through the thought process that astronomers go through to answer the question of what type of galaxy do you see at the center of this image, so that the general public could help them with this. So I'm looking at this galaxy, and I think that I see sort of features. I kind of see this, like this dip in brightness right here. It almost sort of looks like to me that it's not quite smooth because there's this brightness in the middle. And I kind of see a brightness in one of these features or disks. There's also examples that people could look at, but I'm not sure if I think it quite looks smooth all throughout. So I'm going to say it has features or a disk. And then it takes me to the next question that a researcher would ask. Could this be a disk viewed edge on? Maybe not edge on, but from an angle. So I'm going to say no to edge on. I don't see, is there any sign of a bar feature through the center of the galaxy? I don't see a bar. Is there any sign of a spiral arm pattern? Maybe, but I don't think it's a strong sign of a spiral arm. I would say that how prominent is the center bulge? I would say it's obvious, not dominant, but obvious. And you're just kind of going through the same questions that they're asking. I don't see anything that matches up with the this merger question. Is the galaxy currently merging, or is there any sign of tidal debris? I would say no. Is there anything weird? I don't see anything overlapping it. I don't think I noticed any of these weird things, which are all sort of given as an example in here of whether there's like a dust trail or overlapping or lenses. I'm going to say done. And then it asks you, do you want to discuss the image? I'm going to say no. But this is the project that you're really going to be working with. And so we kind of wanted to talk to you about like how this project got developed and where the data is coming from, what data you'll be playing around with. But those researchers that developed this project have made it possible for a lot of projects to be able to be done. A lot of astronomers couldn't ask the questions about galaxies without our volunteers going onto that website and helping to classify what those galaxies are. So when somebody classifies in Galaxy Zoo, there's data linked to each of their classifications. And we get a consensus on each of their classifications. So we know the object ID, so there's an identification number for each galaxy. There's right ascension declination, which is sort of like saying latitude or longitude here on Earth, but for up in the sky. Now I will say the mapper on our tools, you cannot use right ascension declination. It will get confused because it'll map it to the Earth. And right ascension declination does not quite work exactly the same as on the Earth. So you can't map it on the mapper. But you get a link that takes you to a thumbnail of that galaxy, so you can even look at that galaxy itself. Actually, I think it may take you to even more data if you were interested. Yeah, it takes you to this page, which gives you the magnitudes and the different filters that the SDSS telescope measures in. It can give you the spectrum of that star. You can see the image of the galaxy. There's a lot of different things that you can get from this. And I encourage you to go back and to look at this. You can also get redshift, which is a measure of distance from us to the galaxy, because it tells us, I don't know if you learned about this in your physics class, but it tells you about it moving away from us, so that can tell us about the distance the galaxy is from us. We also have the consensus data of whether it is classified as an elliptical galaxy or as a spiral galaxy. So when you go to the data, there's this P elliptical, P spiral, and the astronomers behind this project have said that if one of these values is 0.8 or higher, then it's of that type of galaxy. So for this galaxy right here, the P spiral is 0.84, so it's higher than 0.8. It's 0.8 or higher. So this galaxy is a spiral galaxy. That is what it has been classified as when taking into account the consensus of, I think it's 40 people look at each galaxy. I can't remember exactly. It's either 20 or 40, which I know are way off from each other, but it's a good number of people. So if 14 out of 20 people say it's a spiral galaxy, it likely is a spiral galaxy. but they have the cutoff at 0.8. So 85% of the people who classified this galaxy classified it as a spiral based on the questions, how they answered them. Oh, thank you, Laura. And then you get your magnitudes, just as we use the B magnitude and the V magnitude to get that color index. You have, they do use a different filtering system with the SDSS data. And if you go to your data, you'll see that it's a U, a G, an R, a Z magnitude. And that's what we have listed here. But the color index that they use to be able to determine B minus V, that temperature, that inverted temperature relationship, they actually use G minus R. So the G magnitude and the R magnitude instead of B minus V, since this is a different filtering system. And it's just using different color filters. Some of them can be more accurate than others, so they may have used this filtering system based on the type of telescope. Thank you, Laura, again. And then we also have stellar mass for each, stellar mass, which gives you the mass of the galaxy in solar masses. So they're pretty massive. They'll look pretty massive in comparison to the sun, because these are galaxies. And then you're given, this is the radius enclosing about 50 to 90%. Oh yeah, so there's one for enclosing 50%, half of the light coming from that galaxy, and then the radius enclosing 90% of that galaxy. So that gives you like a more idea of how big that galaxy is. We also have density. So that is how many nearby galaxies are within a certain distance. And then near cluster distance, so the closest cluster of galaxies, the mass of the nearest cluster of galaxies. So this is just the data that you get with the sheet that you'll be given. But we have it all described here so that you can go back and look at it. But if you wanted to do like an HR diagram sort of thing, just know that it's G minus R instead of the B minus A. But it's the same temperature relationship that you had found. This also gives you sort of the similar plot of what you saw in this activity, where we had the different filters shown in the black body curve. So that gives you where the filters are showing in the black body curve. All right, so there's also this bit about galaxy classification. Hubble had really started this whole thing of the tuning fork, galaxies going one way or another. So you have your elliptical galaxies, and then you have your spiral galaxies, but spiral galaxies can be different types. They can be barred spirals, or they can be just regular spirals without a bar in them. They can be irregular or weird. We've just given you one. We're just giving you data of whether it's elliptical or whether it's a spiral. But there are different types of galaxies, and it can really tell you about the evolution of galaxies, is what our astronomers behind this project have learned. And then we have a little thing about showing you what the different types are. giving you examples, and these are images that were used in Galaxy Zoo and were classified in Galaxy Zoo. And some of our irregular galaxies, but again, I don't think that we haven't given you information on whether the galaxy is irregular or not. Okay. All right. But yeah, we just kind of wanted to go through this briefly with you. Why do galaxies come in different colors? So something else that I didn't mention, so those, I haven't mentioned yet because we haven't really talked about galaxies until talking about Galaxy Zoo. The blue galaxies, they have all of those stars that are live fast, die young stars that we talked about from this HR diagram. And so typically they have younger stars in them because those blue stars are high mass and they're burning fuel a lot faster, so they have shorter lifetimes. So they're younger stars. But those more red stars are going to be older. Typically they don't have if a galaxy is more red in color, they aren't having a lot of star formation. It can tell you that there aren't younger stars, bluer stars in there. So that is something to know. Why is there different types of colors, or different colors of galaxies? Which in the introductory activity, you'll be dealing with a question related to the color and this this fact, this statement right here, where it's about younger or older stars in that galaxy. What have astronomers done with Galaxy Zoo data? We have some links, and there is the Galaxy Zoo blog that can tell you more information. But just some cool things that astronomers have been able to do with Galaxy Zoo data is some of our volunteers on Galaxy Zoo have pointed out things that they thought were weird. So this girl named Hanny in the Netherlands, she was a fan of Queen, and one of the members of Queen, Brian May, he's an astronomer, and she was looking, I think she was looking at his blog, and he suggested to her suggested to his fans to go check out Galaxy Zoo. She went on there, she started classifying. She actually is a music teacher. So she's not a scientist. She's a good example of people who help classify on Galaxy Zoo. And she just was like, what is this thing off to the side of this galaxy? And she's from the Netherlands, so she said, I don't know how to say this correctly, but I usually say Worver. If anybody knows how to say it correctly, go ahead and say it correctly. But she said, and that word in Dutch means thingy. And she's like, what's this thingy over here in the corner? And astronomers had never seen anything like that before. And so she ended up discovering something completely new, a rare object that ended up being named after her, Hanny's Vorwer, or Vorwer, I don't know. But she discovered this. It's somebody who just got involved in this project, ended up discovering something new and creating a new thing to study in astronomy, or to even look for in astronomy. So there's new discoveries that have been made. There's studies on different types of galaxies, like dust lanes in early type galaxies, or looking at how do bars form in galaxies. looking into the environment that certain types of galaxies are in. So what other types of galaxies are around that type of, and looking at how do ellipticals form, how do spirals form. So this project has made a lot more things possible. And at the bottom of this document, we do have a link to the blog if you wanted to look for more information that the researchers behind the project have posted. There's a discussion forum you can check out. But yes, we have a lot of information on Galaxy Zoo. So if you have any questions about Galaxy Zoo or the data that you're going to be using for the research project?
So where are these documents?
So this document that I've been scrolling through, there's a link to it from the instructions that Laura sent out.
Okay.
And maybe I'll ask Laura, if you could like resend an email with this instructions so that people can get to it.
Yeah,
but the
definitely.
first thing that we suggest you guys read through for week 1 of the project. Yes. But yeah, let's kind of maybe go through the timeline. You think that's a good idea, Laura?
Yes, that's great. This is really good, Julie.
All right, good. So we'll wrap things up kind of just to go through the timeline of what we expect from you. And we hope that at the end of each week you'll give us just completely honest feedback. Like even if the timeline seems unreasonable, we are going to include like a little section. We're gonna like send you we will send you a survey at the end of each week, and you can just be completely honest with us. Like it seemed like an unreasonable amount of time, whatever. Whatever feedback you have, as well as just a couple questions or maybe just one question about that particular week's milestone. So for week 1, we'll ask you to read through that sheet that I sort of briefly went through. There's also a YouTube video, pinball process of science that we'll ask you to watch. And then within the first week, we also want you to complete the introductory activity, which kind of guides you through answering a research question that we already know the answer to, but it's something to sort of kind of get the ball rolling and make sure to give you a little more practice with using the tools. But then you'll also develop a research question for that week, and at the end of that week, we'll have you send your research question to Laura. But we have like a rubric here as well to help guide you to developing a good research question. Yeah, so there'll be 2 things that you have to do to send to Laura at the end of your first week. So you'll email Laura your complete introductory activity, and then you'll email Laura your research question and the hypothesis that you have for that research question. So what do you think the answer is? Then week 2, you really want to start to visualize your data, kind of how we were doing today, where we were using plots. You can graph things all you want, look at the statistics. So just sending a copy of your data sheet, that'll be kind of like this, to Laura so that she can see that you've been working to try to answer your research question. Then at the end of week 3, you'll hopefully have developed a video based on like your interpretations of the data that you visualized. What is it telling you? What do you think the answer to your question is? There's more instructions below on what we're expecting for that video. And then also at the end of week 3, we'll ask you to peer review somebody else's video, because there'll be about 8 or 10 of you doing this, somewhere around there, and so you'll look at other people's videos to peer review, and we have peer review instructions as well. And then at the end of week 4, we'll give you a survey, and then we'll have like another chat like this. But I think it might be individual for that. Is that correct, Laura? That there will be individual setups with everyone, just to get feedback?
You know, I think so. It'll depend a bit on what kind of feedback we get in the surveys and how we may group some people together. We'll see.
Okay. So yeah, so that will be everything that we expect of you, and you can get that. If there's anything on this document that you feel is missing, just email Laura and we'll fill you in on that. Does anybody have any questions so far? Okay. Then I think that is it. Yeah, we're very thankful that you guys can help us out with this. Laura, do you have anything else to say?
Just occasionally in the instructions you might see phrasing like discuss with your group XYZ and come to a consensus. In the undergraduate course, the students will be working in groups. Here, of course, you'll be working individually just because you're all over the world, even right now. So ignore those instructions where it says discuss as a group. And then, as Julie has mentioned, but again, don't hesitate to email the moment you come into any questions or confusion. We don't want you to spin your wheels unnecessarily on anything, especially because really our goal for you is that you give us feedback on what's working and what's not. So email us immediately if some question comes up.
Are there any questions right now before we let you guys go? I should probably make it so you can actually see my face again. How do I stop screen sharing? There we go. Hi. Any other questions before we end the call? No? All right. Awesome. Do email us if you have any questions. And everybody who watches this later, do email us if you have any questions. All right. Well, thank you, everyone. It was great to see 2 of your faces. And hope that you get a lot out of this as well as us helping us out. So, yeah. All right, everyone. Thank you, and
thanks, Julie. I'm going to end the broadcast now. Let's see if it goes to YouTube the way we expect it to.